Welcome to Lab 10, Conservation of Mechanical Energy. In this lab, we will be measuring the velocity of a pendulum at the bottom of its arc and comparing that velocity to a predicted velocity found using conservation of energy. We know that conservation of energy states that all of the initial energy must equal all of the final energy. Applied to our system, this simplifies to just the initial potential energy equals the final kinetic energy. And you should be able to explain why these are zero and be grateful for that, because we can easily find the final velocity, the velocity at the bottom of the pendulum swing, by simply rearranging the conservation statement to this. Do note that there is no mass dependence here, so if you measured the mass of your pendulum, well, sorry. But also, this is interesting because, at least theoretically, if you swept through the same height, you could have put whatever mass you wish and found the same velocity. Well, that wasn't too bad. So let's move on to uncertainty. We'll go over our measurements briefly and see what needs to be accounted for as far as error goes. Naturally, the error in our photo gate is back again. I'll move swiftly on because you should know how to handle this already. The measurements for our height are here, and nothing especially difficult here. Just remember that when you add or subtract error, you add the absolute uncertainty, and when you take the square root of error, you have the percent error. So if you're thinking, oh well, I better be pretty good about these two measurements because it looks like they're not really all that uncertain at all, you're correct. You should get two values that are pretty close together for velocity.